In part A of this video, on the previous YouTube video, we found the mean because we need the mean and the standard deviation in order to get the z-scores so that we can find the expected frequency because we're assuming normal. So what we're going to do is we're going to divide up each of these classes as far as the amount of standard deviations, and then we're going to figure out how many would be expected, assuming a normal distribution. Okay, so here's something that's worth mentioning though. Earlier in the other video, we got a mean that's different than our mean here, and let me tell you what happened and why. What I did was I made the video early in the day, and I got a mean of 69.4 or something. And then, I logged out and left and came back home and then, wanted to make the rest of the video. But I guess I got logged out. So when I logged in to go back to the questions so we can look at their explanation and talk about it, where they're coming from, it gave me different data here. Like this, I think this number was a 20 earlier, and I think that was a 64. It gave me different data. But what's good for us is in Excel, if you change the values, then it'll change everything that's dependent on it. So the answer that, like when this number was a 20, and that number was a 64 or whatever it was, and I think some of the other numbers changed, then we got a different value here. But what's good is with Excel is it doesn't really punish us for doing more than one recording session. Okay, I think this is 21 and 63. I believe. Yeah. Okay. So I didn't mean to talk about that too long. Okay. So we've already found the mean. So now we want to find the variance. So remember, and then the standard deviation. We're dealing with sample data. So the formula, we're going to divide by n minus 1 instead of n because we want our result to be unbiased. I just want to scroll back there to show you. Okay, good. Alright, so here's the formula they're telling us for the standard deviation. It looks a little bit different because this is the one for group data. See here, you get the difference from the mean, the square difference from the mean for each class, and then you multiply by the frequency because it's weighted. Like that will essentially add up for each one in the class, and then you do that for all the classes. You add them all up, and then because it's a sample, we divide by n minus 1. I didn't mean to get messy. It's just it helps to get in there and talk about it. So I prepped the spreadsheet a little bit. So here, x minus mean. The mean is that value that we calculated. This weighted mean. So the x is going to be our class midpoint. So we're gonna say that this is going to be equal to this x, or the midpoint, minus the mean. And I want to make this cell a reference cell, so we have to put the dollar signs in there because if not, then it'll go to the cell below it, and below that, and then it'll continue. So that's why the dollar signs are over here in the formula. So when we drag it down here. Oh, my mouse is not cooperating. Okay, I don't know what's going on, but yeah. So let's drag this down, and because we used a reference cell, then it's going to subtract in this case E5. This midpoint 63 minus the 69.21. It's noticed that it's still D12 here, and then it'll be D6 if we go to the cell below it, but it's still D12 there. Yeah. Right, I'm talking about D12 here. Okay, so we get x minus mean, and notice if we are going to find that sum, and I'll use the auto sum, it's not going to be 0 because we're dealing with group data. So we don't have that positives and negatives canceling out like we did earlier. So I'm going to undo that. I just wanted to remind you that we are dealing with root beta here. So it's different. So, but we find the square difference from the mean. So we're gonna square the previous. So we're gonna raise that to the second power, and we want to do that for all the classes, all the groups. Okay, and then we want to multiply by f because it's weighted. Because here there's 21 tests here in this class, and we find the difference from the midpoint, and we square that, and then we multiply by 21 because there's 21 scores that we're kind of adding up, and we're using the midpoint as the estimator because we don't know what they are. We just know that there's 21 between in that class. Okay, so that we're just going to multiply. This is going to be equal to x minus the mean times f, and the frequency is over here, and we want to get that for each class. So we get all 200 scores. So this is like adding up. Okay, I don't know if that worked. Okay, I8 times D8. Good. Okay, good. So what this does is it gets, for all 200 tests, it gives the square difference from the mean for each one, using the midpoint as the estimator for each value in the class. Okay, so let's do the auto sum thing because we want to get the sample variance. So we have to get the sum of all the square differences. So let's use the auto sum, and then we want to divide that by, for the variance, the sample variance, I already put the formula in there. We want to divide that by n minus 1 because it's sample variance. So that's going to be this cell, the sum divided by 199. So that's sample variance. And then the sample standard deviation is going to be the square root. So we're going to get this 8.625. And I'm going to flip through here. But I think it really helps to see it in a spreadsheet instead of just written out with all this stuff, just to really realize where stuff is coming from. Okay, so now the z-scores, let me look at time. I don't want to get started. Yeah, let me make another video for the rest of this. I'll stop here for this moment.